Hello, and welcome to Clips.marketing, episode number 34. Chris, I made a car drive itself, and it was amazing. You
awesome.
just plug it in. Oh my gosh, it was this kit. $1,200. Bada boom. You just man in the middle attack, the camera in the top, pop off this piece of plastic, run this wire down to connect to the OBD2 connector. You got to hit next a whole bunch of times on this Android screen. You have to type in a URL of the software to do, and then it just drives itself. And it's not good at stop signs or stoplights, but otherwise it's just perfectly staying in the lanes. You tell it the maximum speed it can possibly go, and it does adaptive cruise control with the car ahead of you. And it's amazing. And I'm just sitting there, and for the first, I don't know, half hour I was driving this thing, I just couldn't get over how cool it was. And then I had little snippets of moments of, oh, this is normal. This is just, yeah, my car drives itself now. And it's amazing. What an incredible, practical, useful application of all the stuff that you're working on, of machine learning and artificial intelligence. Like, to be able to sit in the car and trust my life to these algorithms, it was incredible. Good job, humans. We've done some really cool stuff. So that's what I'm most excited about right now.
That's cool.
It's very cool.
Cool. I do notice you introed us as clips.marketing instead of makers.dev. Is that the second thing that you worked on this week?
Oh, I sure did. Yeah. That's my brain's all frazzled, just like the computers have driven themselves. Yeah, I got an OAuth integration with clips.marketing to Twitter. And I have some thoughts about that, but we can dig into it later. Yeah. Oh, so exciting. The thing that I built this machine for when I started building it, I think 6 months ago is when I first started talking about it. It's almost there. It's these two things that need to connect, of this whole pipeline to be able to build video, and then this whole pipeline to be able to syndicate them out and copy what Buffer does. I've built out the syndicating part, and ooh, it's like right here. And then I've built out the clipping part, and ooh, it's right here. And I think every week I say it's going to be one more week, but for real this time, I think it's going to be one more week of just connecting these two little pieces. And then I'll be able to be syndicating these clips out with minimal effort on my part. Good, exciting things are happening. How about you? How was your week? What are you up to?
I had some exciting and some very not exciting. I hurt myself while sleeping this week, which is a thing you can do in your 30s, I guess. Yeah, my arm fell asleep, and I whipped it over real fast, and I pulled something in the back of my neck. So for about 3 days, I had to look straight ahead. I couldn't look up or down.
Oh my gosh, what an old man story.
I know. Yeah, so that was interesting. It gave me a lot of time to just sit, though, because I didn't want to move because it hurt. And so I just sat. I learned a whole lot more about GPS. So last week I was stuck on this GPS thing. I didn't know, exactly where to go. I had lots of avenues I could take it, and no real insight or knowledge into which avenue was the best, or that anyone would work particularly well. So I just started going down the GPS rabbit hole some more. I took this whole university class that's online, like a an old Stanford class. I read a PhD thesis. I read several articles about it. Yeah, I think I have a much better understanding of it. I can just about replicate their baseline results now, which are worse than the results I currently have, which means I'm no closer to getting any better, but I understand all of the little bits and bobs now. So, yeah, so that's what I did. I don't know what I'm going to do with this information, but it was very interesting doing a deep dive into it.
I'm so curious about that. Talk to me about GPS. My current understanding is there are satellites in space that know exactly what time it is. And you have a receiver on the ground that's listening to the satellites say, hey, I'm this satellite, here's where I am, and here's what time it is. And from that, you can calculate how far away it is, because you're calculating the speed of light. And if you did that with one satellite, you'd be able to figure out, I'm within this sphere, this disk on the Earth. And if you do that with two satellites, now you have two disks, and those intersect at 2 points. So now you have 2 points where you could be on the Earth. And if you do that with 3 satellites, you know exactly where you are. And that is my current understanding of GPS. I would love to know more, and I would love for that understanding to be corrected if it's wrong.
Yeah, no, that is very close to right. You actually need 4 satellites because, yes, the satellites know exactly what time it is down to the nanosecond, but your phone may be a second or 2 or a minute off, So you need a 4th satellite, which corrects for your user clock offset.
Oh, the phone doesn't have to know perfectly what time it is. That's very interesting. Right. Okay.
Yeah. So
and now I'm just going off the satellites because the satellites always know exactly what time it is.
Yep, exactly. Or they actually know what time they know it is and how far that is off from the actual time. It actually drifts by a few nanoseconds, but they can correct for that. So
Interesting.
yeah.
Because of relativity, because they're moving so fast.
So yes, actually, relativity plays into it. That is all automatically accounted for, but and then there's different errors that can happen. But yeah, relativity actually matters because you're talking about nanoseconds and going very
How
fast.
weird.
So, yeah.
I have a question for you. How do they know what time it is? Before we launched them, did we sync them all up? And did we sync them all up at the same time?
So there's a few different ways. Basically, so the clock, like on your wrist or in your phone or whatever, is an oscillator, right? And it keeps approximate time down to maybe the drift is a few nano or milliseconds every day or whatever. The clocks on GPS, they use radioactive decay, as far as I understand, that is down. The accuracy of that is past nanoseconds. And so when we launch it, they have an oscillator in them that radioactively decays and exactly tells them what time it is in nanoseconds.
I'm surprised radioactive decay would be more accurate than quartz. I thought quartz was like the gold standard, and you couldn't get better than that. The idea that
you can't get better than that for cheaper. The clocks and the satellites cost $1 million, not 5 cents.
Sure. It's surprising to me that radioactive decay is more reliable than a quartz crystal vibrating. I would think. Well, I guess if you had like enough of the stuff that was decaying and you knew what rate it decayed, that any error in that would sort of average out.
Calling it radioactive decay, like measuring that, may not be exactly right. It's radioactive something.
Okay.
Yeah.
I'm curious about that. Hit me with some more fun facts about GPS. What else did you learn about how this works?
Sure. So if you were in a vacuum and knew exactly where things were and had the time of light and everything, the speed of light, then you could identify yourself with 4 satellites. We're not in a vacuum. We are on the Earth, which has atmosphere. So the atmosphere affects how fast the waves travel. You also have things like buildings and mountains and whatever, which can reflect or deflect the satellite signals. There's a few other sources of error, and the antenna in the phones is not that great, and so it naturally has error because it's the cheapest. They make it the cheapest that they possibly can. So all of that adds up to more error, which gets you down to 5 to 10 meters or so, which is what their baseline is. And so that's what I was having real trouble replicating. It turned the way that GPS is sent. So it's like sort of there are file formats that have been developed over 2 decades or 3 decades, I guess, and so you have to go dig through specifications and there's version numbers, and it's very difficult to even understand what's going on. Also, they don't use UTC time because UTC time has leap seconds, and you can't have leap seconds, and so they use something called GPS time, which is seconds since 1980 without leap seconds. And so converting between the two is very difficult. Also, you have to worry about things like the Earth rotating and satellites moving, and it's just a lot more information than I've had to deal with before. I'm doing it partly because it's a lot of the math that I have to review anyway. So there's a lot of matrices, there's a lot of math involved, and so I don't feel that bad wasting my time. I'll say learning about it. There's just a lot. It's just a lot of information to parse, and if you get any one thing wrong, then you just get the wrong answer, and you have to go back. It's kind of like programming. You got to go back and figure out what in the world you did wrong. So very interesting stuff.
That's fascinating. I love that time is so difficult to do, and we have our own conceptions of time and don't want things like the time to drift. We want 7 a.m. now to be about what 7 a.m. felt like when we were children, and because of that, we have leap seconds, and on the scale of the year, the same sort of problem, we have leap days. But that just makes it so difficult. Scientifically, we need this to be constant. We need to know and have very simple ways to figure it out. I was obsessed for a while with this project called Swatch Beats or Internet Time, and the idea of that is that it's a simplification of all of time. It's like, actually no, it would still suffer from the leap seconds problem, huh? The idea of beats is that it takes Greenwich Mean Time, and instead of having time zones, it's the same time everywhere in the world, and instead of seconds and minutes and hours, it's a beat, and a beat is 1/1000th of a day, which works out to I think about 3.5 minutes. And so I'm fascinated by alternate systems of time, and I love that GPS time seems to be more scientific. Like, if I could pick a standard, I think I would rather it be that, because JavaScript timestamps. Actually, no, that might be better because JavaScript timestamps don't take into account leap seconds. That is the number of nanoseconds since that epoch time. Is that right?
Okay, so leap seconds in JavaScript, you can duplicate a second. Yeah, so leap second duplicates a second. So there's been 18 seconds since 1980 that have had two of those values. So a leap second happens because well, not exactly. A leap second happens because you go, 58, 59, and then instead of the minute rolling over, you go 60 and then 01.
Okay.
Or then 00. I mean, sorry. So you have an extra second.
Does that affect JavaScript timestamps? If I print out, if I do a new date, oh, that's awful. Yeah. Oh man, how I thought we had figured it out with just a timestamp. Oh no, because then you just need to have a whole bunch of if statements of like, if the date is after this number of times that we've had leap seconds, then add or subtract this number of milliseconds from the total. That's terrible. Okay, man, that's a new dimension to time that I didn't know happened.
Yeah. I mean, you don't.
Gross.
People just ignore it, which is how web developers deal with it. But you're
on the scale of a second, I guess that for practical things that doesn't really matter. But if it really matters, how exactly what time it is, like we're working with the speed of light here. I would love for everything to just be on the same time. Why don't? Gosh, let's switch JavaScript timestamps over to GPS time. That seems like it shouldn't break too many things, and inevitably it'll like accidentally cause a nuclear reactor to explode. Who knows? That's funny. Man, time. Wait, let's figure it out, humans. Come on.
Right.
What is the data that you're dealing with in this problem? Are you looking at like a spreadsheet of the raw messages that you're getting from specific satellites? Like what does a row in this look like? Is it like satellite ID and the position it thinks it's at and the time it thinks it is? What does that look like?
So they presented it in a few different formats, which is sort of nice, I suppose. They have the baseline, which is, as far as I can tell, what most of the teams are dealing with, and that is they already calculated, based on sort of a standard kind of way to do calculations, what the baseline is. And that was about 7 meters accuracy, which is about right, 5 to 10 meters. And that is easy because that's just like latitude and longitudes and timestamps. And so like no satellites involved if you want to deal just with that. Then they also have IMU data, so like sensor data, so acceleration, gyroscope, and magnetometer, in case you want to do that. And then they have the GPS logs in a few different ways. They have the very raw GPS log, so yes, the actual message from the satellite. They have a sort of a industry standard way to present that information. So it's like parsed basically in rows and stuff. And then they have what they call a derived value, which is they already did the calculation for some calculations for you based on that data. And so you can parse that without having the knowledge of the detailed underlying format. But you also can't, like, you lose, like, they did that parsing and some calculations for you. And so if you want to do those a different way to get a better result, then you have to go all the way down to the very base information.
Which is what you're doing, I assume.
Yeah, that's what I'm doing now.
Amazing. Man, how cool is that? Because this was spy secret technology, like, not that long ago, 30-ish years ago. And you're working with the raw data, and you have a reasonable shot at, like, being able to interpret that data better than anyone else has before. Like, that's a reasonable thing that you could be doing, you and your computer. Is that fair to say?
I am currently trying to interpret it as well as your smartphone already can, which is kind of I'm trying to solve the known problem of you have GPS. Once I get to there, then the idea is maybe you can go do better than that. But I am not even there yet, and no one else is. I can tell no one else is because the best accuracy right now is 3.5 meters, which is there's like 3.7 or something, which is still they're just using the baseline data still. Almost certainly they're not. Yeah, whoever wins this is going to finally crack the GPS code and then get down to a meter or sub-meter. And so that's what I'm trying to do, but I'm not there yet.
How fun. So presumably the way that we're the current algorithms in phones, I imagine that's based off of algorithms that humans have written. That's declarative code that's, okay, do all the math for calculating leap seconds and do all the math for calculating speed of light. And that's gotten really good. But if we take this hammer of machine intelligence, machine learning, and just throw it at like, here's all the data, and it's as clean as we can possibly get it for you. I've taken you to the point where you can sort of fiddle with the things that should be fiddled with. Like, okay, maybe the rotation of the satellite actually matters, and that's not something that humans have been taking into account. It may be that the machine could find a way to use the rotation of the machine in part of the calculation in a novel way that no human has done before, and that by just framing the problem for the computer in a easily digestible enough format, that there could be a better algorithm. We could have another binary blob of, okay, it's this neural network with these weights in this way that gets you sub-meter accuracy. Is that the game?
Yeah, that's the hope. That's the hope of the competition. Is that no one has solved it yet, and there's less than a month to go, and so like I only have a few more weeks to get this right, and I don't know that I will. So, and I don't know that anybody will. So we'll see. Yeah.
It seems like the sort of thing you should get a Nobel Prize for. Like you're able to do it, just like based on existing data, have GPS more accurate. How much would that benefit the world?
I mean, you could at least get like a PhD probably out of it if you did it right.
Cool. That'd be a fast way to get your PhD. Don't even worry about school. Just solve this problem. You're done. Man, how fun. Inspired by you and being able to viscerally experience this magic of machine learning in person. And it's touched different parts of my life. Like, when Alexa first came out, that blew my mind. And it was using similar techniques. And, autocomplete's pretty cool. And but something about being in a car, just like this thing that I've done my whole life, and I drove it on the street where I learned to drive. And I'm watching this thing drive better than I can drive now. It was just mind-blowing of, oh my gosh, this is a skill set I need to be paying attention to. This is a very important new area of programming that I have like two ideas of things where I would use this immediately, but I don't see myself like being able to compete on Kaggle or that this is going to be a significant area that I'm going to be working in. But I really need to be familiar with these tools because they've gotten to the point where they can drive cars. They can drive a car, Chris. It's amazing. And like from a camera. And, the areas where it's weak right now of not being able to stop at stoplights and not being able to stop at stop signs, and also like it doesn't know when it needs to switch lanes. It's not hooked up to your GPS. I think Tesla's starting to do some stuff with that. But all of those things are software updates. That's just, can we get a better model? Can we get a better training data? Can we get a better binary of what this brain looks like that we can push down to it? And then presumably with the exact same hardware, okay, now it can do all those things. And now you just tell it where you want to go, and it's able to go there. I have started a book that you recommended, this fantastic Learning Tensorflow.js. Ooh, I'm this way through it. It's about halfway through
Awesome.
For people who aren't watching the video. I love it. It's great. One of the biggest insights I've had in this is that I don't need to know the intricacies of this. It's valuable for me just to know, like, okay, where are the black boxes and how can I connect things? I didn't know that TF Hub was a thing. TF Hub is this repository of all of these pre-built networks. So I don't need to build anything. I just need to say, okay, I have a basic understanding of tensors and that those are matrices that are built in this special way that they can be operated on in the GPU. And like, here's how I translate an array into a tensor. And then here's how I run this calculation of this black box that I download from TF Hub. And then here's how I take that end results of another tensor and translate that back into an array and then do the data massaging. Like, just knowing how those pieces connect, not knowing anything about how to train data, not knowing anything about how to do the research of like the raw bytes of, okay, I'm analyzing images and I need to do that and I need to have a big enough training set. It's valuable because I can take all of this stuff that people have already done and I can now plug it into my app. I was amazed in the show Silicon Valley, the app that they made as a spoof, is it a hot dog app that you point your camera at a hot dog and it says, yes, this is a hot dog, and you point it at something else and it says it's not a hot dog. I had viewed that app previously as like, ooh, that seems like some complicated machine learning. was surprised to find that there is just a pre-built neural network that takes any image, and you have to do some massaging of like it has to be the right size, and the RGB values have to be scaled between 0 and 1. But then after you connect this, you just take any image or any video feed or anything else, and this runs like multiple times a second. You can be feeding it 60 frame per second video. I feel like I could make that app now, just having perused this book. That's insanely powerful, and I can see how. Wow, if I had enough understanding of this, I could take any arbitrary problem in novel ways. If I wanted to identify certain types of pictures on my phone that, like, maybe it's not one of those 1001 things that are identified by the pre-existing models. It looks like by the end of this book, I'm going to be able to make those networks, and that is so exciting. What a cool method of programming, and I only see this being more valuable in the future.
Yeah, something I think Tensorflow.js especially gets really right is they really push hard on you don't have to build the model yourself. You can use these pre-trained ones. The TensorFlow documentation, like the Python version, starts with like here's a tensor and here's getting started and stuff. The TensorFlow.js one starts with here's all the models, the pre-trained models you can use, and how to use them. And so it's actually a different way of looking at it, and so it's super valuable to like web developers or anyone because you don't have to actually build the model. It's already built for you. You just have to hook it up. Also, the not hot dog app. Do you know the story about that one?
No, I don't.
So that they made that app for the show. It's a real app, and they made it for the show. And and the person who made it was a Fast AI student, and so they didn't know anything about programming or not about deep learning. They went into Fast AI, and Jeremy Howard, the person who teaches Fast AI, has a funny story about them because they were working on a TV show, so they couldn't exactly ask him the question that they wanted to. But they're like, say you have lots of pictures of corn, and you want to be able to know if it's corn or if it's just a yellow block. How would you? And then say you want to put it on a phone. How would you reduce that? And so it's like all these like weird, kind of sideways questions. But really, he was building this app for HBO, which is pretty cool. Yeah.
That's so funny.
Yeah.
No, I have a friend who's a professional magician who's sort of plugged into Hollywood. He's like been involved in a Netflix documentary, and I've chatted with him and gotten to see some of the behind the scenes of like how these shows are actually put together. So I can totally see how just like a friend of one of the producers knew some coding and got contacted and was like, hey, like you could build this, right? And they were like, oh yeah, sure, absolutely. And you'll get credited on the show if you can figure it out. And they're rushing to figure out like how they can actually do it. Oh, that's so funny. That's a great story. Interesting. The thing I think I'm most curious about is I love the perspective of TensorFlow of how it's it's focused on the making useful things. It's especially the way that this book is written. It's not taking you through like here's the theory behind it and here's how you build the models. It's from chapter 1 you're building a useful thing that can actually do something. What would you say are some of the more interesting pre-built models that you've come across that you think I would be interested in? Some of the things I've seen that are cool are like the image classification one of this thing can look at a picture and it can tell you what's in it. And then you can localize that. You can draw a box around it. Like that seems really cool. And then I've looked and seen that there are some things in audio. There's like a speech to text and a text to speech model, I think, but I can already do that through APIs. I'm not sure if that'd be something useful to dive into. Does anything come to mind of like a thing that you've stumbled across that could get me totally sidetracked on building an app around it instead of doing the work I'm supposed to be doing?
Yes, actually. So you already mentioned image classification. So yeah, image classification in general or image recognition is like a big class of things. You can actually do a lot more than you think because anything you can represent as an image, even if it's not like real imagey, like anything you can generally represent as an image, you can then run through these pre-trained models. And so, for example, say you wanted to, I'm not saying this is a good idea, but say you wanted to predict the stock market, you could take, screenshots of graphs of things and run them as images through the thing. That probably would be worse than just running the actual data through a custom model, but it would be a way to get started. The other big one is text, so anything involving text. And to do that, I wouldn't use TensorFlow.js. I would actually use something called Hugging Face, which is a company that they create these loaders for all of these models, including one called GPT Neo, which is GPT-3. So it's GPT-3's code, essentially. It's the same code, but they trained it themselves, and so the whole thing is open source. It is 2.7 billion parameters instead of 175 billion, so it's a lot smaller. But that's like the difference between 95 and 96% accuracy on things. And so you can do lots of really neat things, and it's completely free and open source. It's a 10 gig file that you have to download once to use it, but then you can just use it. So anything you might use GPT-3 for, which is not just generation, you can do lots of things. You can do like question answering. You can do like text summaries. You can ask GPT-3 or GPT Neo to do lots of different types of tasks involving text. So that is one where if you want access to GPT-3 and you don't yet, then use GPT Neo, I would say.
An idea that we've talked about on the show is this positive feedback bot that you texted a thing that you did, and it says, good job. And there's a very simple way to build that, which is just it says good job every single time, and it says a better good job with the more exclamation marks you have. Like that would be a form of artificial intelligence, but would not be machine learning. How would you approach making that smarter? Like if I wanted to have it more interactive, and if I said like, I caught a very big fish today, I would want it to say something seemingly human about that, of like, good job catching a fish instead of just good job. What would that look like if and how would you architect that also? Would that be, I guess this model I would just store on, if it's 10 gigabytes, I could just throw that on a VPS and then build my own little API that I send it what the prompt is and it sends me back the response. I'm curious what your thoughts are on that, of how you would build that with machine learning.
Yeah, so if you wanted to use something like GPT Neo, then yeah, you have to store it on a server somewhere. You also need a graphics card to use it in any kind of real-time way. CPUs don't work, so you need a in the cloud graphics card to use it. And yeah, you can just send it prompts and see what it gets back. A lot of the work for that is going to be figuring out exactly how to how to phrase the prompt in order to get something useful back. It is not super. It is not that smart, and so you have to like phrase the prompt in really weird ways. One of the ways is like, you are a nice question answering robot, and a customer asks you these questions, and then you have like a question and an answer, question, answer, and then you have your question, and then that's the prompt. And so it's like a couple examples of how you want it to answer, and then their question, and then it will like basically complete that text. And so getting that exact prompt right is tricky. The other thing is that there's like lots of different parameters that you would be messing with, so that's tricky. And so all this to say, if you were going to do this, I would start with the simple version. Like generate, like write down 100 different like good job things, and then just text a random one of those out, and then I would roll this in slowly. And if you can't hit your service in less than 2 seconds or something, then fall back to one of the pre-trained ones or something. Yeah.
I have several follow-up questions. First of all, how amazing is it that I can just give it a few examples of any problem that it's able to figure it out? What a strange way to program. But like, yes, of course, that's how humans learn. You say, okay, we're going to learn calculus today. Here's an example of a problem, and here's the correct answer, and here's another example of a problem, and here's the correct answer, and now here's another problem. Tell me what the answer is. Amazing. Okay, so I'm hearing that it would be valuable for me to have a database of that question answer of how it would ideally be trained. So what if I start with this as all of the texts from the service are coming to me, and I am personally responding to each one, and now I have those pairs of like, if someone says this, I expect you to say something like this. Is this the sort of thing that I can feed it? Like, can I feed it 1,000 of those question and response answers, or would that be no better than just having 3?
So yes, with GPT-3 you can't do this, but with GPT Neo you can actually fine-tune it beforehand. So that's probably what you do if you had 1,000 of these things. Then you can fine-tune GPT Neo to you're kind of pre-telling it how you want it to answer, and then every query doesn't have to be 1,000 examples. You sort of pre-tell it those examples. So yeah, that's probably how you do that if you had 1,000. If you just have like 2 or 3, then you just give it the query, and it's called like few or one-shot learning, where you basically give it the examples in the query, and then it returns But the other way, if you had 1,000, then you could sort of pre-train or fine-tune the model, so it'd give you what you want.
That is so cool. Wow. Okay, second question. When I'm deploying this, is there a standard way of deploying it? Like, is there a Heroku for machine learning? I know part of Firebase is that they have like a TensorFlow area of that, and I still don't understand what that is. Is there a standard way of deploying these GPT Neo things? Are there like serverless functions that are tuned to do this?
I don't know about so you actually wouldn't want serverless because so I can talk about why, but most people use AWS or Google Cloud.
Okay.
They both have GPU options. The reason you don't want serverless is because there's a spin up time. So you have to load that 10 gigabyte file into memory, which is takes 30 seconds or a minute or something. So if you had a serverless function, then every time you hit it, you'd have to load that into memory, which is super inefficient. And so you would want to load it. It would take 30 seconds to a minute to spin up once, and then you would have instant access to it.
Cool. For the types of VPS instances that I would need to be able to do this, are we talking like $20 a month? Are we talking like $100 a month for something with a GPU that's beefy enough?
More than $20 a month. I don't know what the actual numbers are, but yeah, you can find out on Amazon. There's probably like I don't know. I'd have to look. Because I was looking at the high end GPUs and those were like $1 an hour, but I don't think you need one of those. Okay. But you do need more than $20 a month, kind of. Yeah.
And for reasonable response times, I would need it to be running continually.
Yeah.
So that it's warm. Okay.
Yes. So the other thing you do is just use GPT-3 once you get access, right? And so there's that. But they have their servers spun up all the time, and they're actually faster than some of the GPT Neo times I've been seeing, and I'm not quite sure why. So they're doing some special tricks there, and so the rates for their API are pretty reasonable. And so, yeah, once you get access to GPT-3, I would use that. But until then, yeah.
Okay, so this is just a stopgap for me to be able to spin this up and like have the code structured in a way that's able to do this. And I like your idea too of having a timeout of like if the API is taking longer than 30 seconds to respond, I can just respond with whatever my canned feedback is. Okay, so what I'm hearing is, I think the way that I want to architect this would be I set up an app with a hotline people can text to say the thing that I did a good job on. And version 0 is I have 10 things that I send back to them of like, good job, way to go, attaboy. And I pick a random one and I text them back, and that's the MVP. The next level up from that, I think, would be I have a timeout where I get a push notification of like, someone would like positive feedback on this, and you have a minute to respond. And if I happen to be on my phone and happen to get that notification, I respond back with a human response that is saying like, you caught a very big fish. That's an impressive thing to do. Maybe I have a little pun in there or something. Oh, jokes would be hard. I'll try to do it in such a way that like it's a response that GPT-3 could have done. So like nothing.
You could ask it to tell a joke. It might work.
Are they funny? Does it tell jokes?
I have not asked it to tell me a joke yet. Yeah, I don't know.
I'm very curious about that. How wild is this that we're talking about this?
The other thing is you said a minute. So if a minute response time is your ETA or whatever, then you can use a CPU. So CPUs take maybe like 30 seconds. So you still want it spun up all the time because that still takes 30 seconds to a minute. But then the response on a CPU is about 30 seconds. And so...
interesting.
Yeah.
I think at least part of the infrastructure of the Google Cloud functions are that it'll do some behind-the-scenes work of like... It'll keep your instance spun up for after you've gotten a response. So if it sounds like from cold, if I text this thing, it's going to take like a maximum of 2 minutes to respond. If I have to start the instance and load the model and then run it through on CPU and not GPU. Is that right?
Yep.
Well, that seems reasonable. Like, it would be great if it was instant, but it's kind of cool that it takes some time to like. It would almost feel more human if it took 2 minutes. And 2 minutes, like if I'm texting a human, that's a perfectly reasonable amount of time for it to text back. Interesting. Okay. So I think I do that with me first. I'm mechanical turking it, and then as soon as I've gotten 100 responses in there, now I turn that over to GPT Neo and I say, hey, here's the call and response. Here's how I expect you to respond for these given responses. And now I want you to be able to respond to anything that someone says with a similar response. And then I hook that up. And if it's on a cloud function and it takes 2 minutes to respond, I would need a beefier CPU for that, wouldn't I? Like, it would be faster the higher the CPU was?
Yes, probably.
Okay. So, but for that amount of CPU time, like if I'm spending 4 minutes of execution time for like a 4 gigabyte model, I'd have to do the calculation. I think it'd be like less than 2 cents per response or something, which is not nothing. That's it'd be a fun experiment to just see what happens. Okay, cool. I have a roadmap.
The other thing you could try is so that's the biggest GPT Neo model. There are smaller ones, and so you could try the smaller ones first. They take less time. Their responses aren't as good, but it might be good enough for what you're doing.
Cool.
Try it.
Noted. I have a question here related to self-driving. Something I was surprised by is that the cars aren't... It's a smartphone camera, and it's pointed out the front of the window, and it's not able to detect stoplights yet. And I would have thought that would have been like the most straightforward thing in the world. It's a very recognizable shape, and it's just the color that it is, if it's and it's even the right position every time. And I'm struggling to think of why it can't do that already. Is that a safety thing, or is it just very technically hard to notice? When you're a couple hundred yards away, it's maybe a single pixel that is the important pixel of what the color is. Do you have any insight into why they wouldn't be doing that already?
So it might be a safety thing, meaning they can do it, but only 99% of the time, and not 99.9999 whatever, so they don't enable it or something like that. Because so it'll probably work great under like perfectly normal conditions, but like if it's raining at all, or if there's a glare, especially sun glare, I know it's a really big problem for camera systems. Then it might interpret a red as green or something. Especially with just a smartphone camera. So like if it's not a really big like lens, then I can definitely see there being lots of problems with detecting things. So like 99.9% is fine, but that like if you're doing that many calculations, then you probably get like an accident every month or something. Without so you need more nines. Basically, it's all about the pace of self-driving is all those nines. And so like how many 0.9s do you need before you're better than not just better than humans, but 10 or 20 times better than humans before humans will really accept it.
Okay,
so that might be
what's happening. I think from an interview with George Hotz, he said a year ago that the system was needing an intervention about once every 10 miles, and the current system, I think, needs an intervention once every 100 miles, which is not nothing. That's, for people commuting, that might be once a week. You have to correct it into doing something. But he was able to 10x it in a year. So presumably, if he does that again, if it's once every 1,000 miles, okay, now we're starting to talk about you can be trusting the system more, especially with things like stoplights. Yeah, okay, maybe stoplights and stop signs are just especially dangerous, and there's just not enough nines on that particular segment yet. Okay, yeah, that makes sense. Interesting. Man, I'm so excited about this. What a cool... just solve any arbitrary problem. It's machine intelligence. It's like, it really feels like that. And it's not just this... I feel like I'm learning how to code again. Like, the problem domain of what types of problems computers are able to do is expanded for me over the last few weeks of talking with you about AI stuff. It's so exciting. It's like the types of apps and the scope of them. I love having this as a thing in my skill set. I'm affirming you doubling down on AI stuff and machine learning. I think is a very good decision. That will not be a bad investment of your time.
Yeah, that's exactly why I'm doing it. I've been seeing the same things, and especially following it I've been following it since college, which is over 10 years ago now. And so just seeing the progress in that amount of time is ridiculous. Like, it really has been like 10x a year for 10 years. So yeah, pretty nuts.
I'm reminded of, I just got a Roomba, or an iLife. It's a knockoff Roomba, and it is so dumb. I was watching it today, trying to get back to its base, and it has a little homing beacon on it. Like, if it can just see it, it's able to go back to it. And I was just watching it make loops around it. It was like just out of its vision, and then it would get stuck in another room and caught under some chairs. And oh my gosh, it was painful to watch. That's the sort of thing that I imagine. I don't know. You have a human driving it around first, and you just collect enough data. So maybe you make a game, and the game is called the Roomba game, and you're actually controlling real people's Roombas in their actual homes. And maybe you get a discount if you let people do this on your Roomba or something, and the trade-off is that you get much better, presumably much better, like, driving of the Roomba, that it knows where its actual base is. Okay, well, now if we have a bunch of data from that, slap a camera on it, now we just take this hammer of machine learn the thing. We have a bunch of data of how a human did this, and it's the same inputs and the same outputs. Great. Figure it out, computer. And then it'll be able to perfectly drive around as if it was a human in any sort of arbitrary thing. Like, my gosh, I feel like my brain's exploding of the different types of problems that we could just throw this at. GPS. Yeah. We've had humans doing that. Let's throw machine learning at it and just see if that can do better. And it probably will be able to, and we won't understand quite how it did it. Oh, amazing. Like, we're in the singularity. This is what it looks like when you're living through it. Oh, it's so exciting.
Yeah. Yeah, at the same time, I mean, that's exactly why, like, so your Roomba example is exactly why people are like, AI, whatever, you know, like, my robot vacuum can't even drive itself around.
Yeah.
Which, in that case, there's a few things happening. One is you're looking at it from above, which is very different than mounting a camera on the thing. So that's very different. Also, it highlights something that AI can't do quite super well right now, which is, like, long-term planning. So, like, long-term route planning is, like, a thing that is tricky. OpenAI is working on it. There's a series of techniques called reinforcement learning, which seem to maybe have like lots of, it's basically like, so for OpenAI, it's how can you play a video game? So if you imagine the Roomba as a video game, you know, what series of moves do I need to do to get there? The problem is it's not exactly working quite yet enough for production. And so it's that we're on the cusp of solving something like that. But right now, all you can see is your robot just dumbly going around in circles or whatever.
It's so dumb. I think it's just random right now. It has just a very simple... It knows how to do walls. It can go around walls really well. And then sometimes it just jets off from the wall in these strange angles, and I don't understand what it's doing. The model that I have doesn't have a camera, so I think it is just blindly going around, which... How amazing is it that humans coding this thing that has very limited senses are able to, like, most of the time, it is able to get back to its base, and it's able to clean my house. It's great. Amazing. And how much better could it be if we're able to have an actual little brain in there? If we had a computer in there that was, you know, as advanced as a little mouse brain or something. How much more complicated is the life of a mouse than this task of vacuum a house? That rhymes. If you had the amount of neurons and the capability that a mouse had, and, you know, it doesn't have to go and find food. It just has to find its little base station of the food is right here. And it doesn't have to reproduce because it's just the one. It doesn't have to, like, rebuild copies of itself. So taking all that capacity and just really hammering home, like, okay, this is your problem. You clean the floor and do that as best as you possibly can. It seems like it would just knock that out of the park. And the limit seems to be both in hardware and software. If we had cheaper, more powerful computers, you know, to say that we have a computer on the scale of a mouse brain, I think is like that. I don't know the numbers offhand, but I think if you measured it in teraflops, that would be like a supercomputer right now. But pretty soon, we're going to be able to shrink that down, and they're going to cost pennies for that type of processing power, and just be able to throw it in a Roomba. It's an exciting world. This excited about humans right now. Good job.
Yeah, you hit it right about cost too, because so that's consumer electronics, which is a whole different thing, right? It's like, you know, if they spent $10, you know, like $5 in parts and $5 in engineering labor per vacuum, then maybe they could make it 10% better or something. But, you know, over 20 million vacuums, that's, you know, $100 million or something, or $200 million, whatever. Which no company's going to do until it's required, you know, until all the other companies are doing it. So it's kind of like an arm race situation there. Like, yeah, unless it, you know, was like several, you know, like 10 times better or something, then you might get there. But yeah,
I see it coming.
Yeah, I mean, yeah, once it gets cheap enough, then you just put it in anyway, and then that's when it gets better. Yeah.
And I want to be there on the forefront. I want to be able to know how that's working and make those brains and apply them to any sort of situation. Oh, how exciting. There's one other thing that seems so boring now that I'd like to talk with you about, of just the flow of, like, connecting Twitter and OAuth. Like, I guess fundamentally it's the same sort of human work. The human work in this is just connecting things. It's just like connecting these pipes of, okay, Twitter, for me to get authenticated to Twitter, it needs to be asked in this very specific way. So let me tell my code to ask it in this specific way. And then when Twitter says, okay, yes, you were verified, it needs to tell my program in this way that is standard, and my program needs to store it in a specific way and take those numbers and flow them in other places. That's the same sort of work that programming in AI is. If you're just connecting stuff, you're taking, okay, this is the data, and the data needs to be in this format, and I'm connecting it. I feel like a plumber. I'm just in all these problem domains, I'm connecting things, but I feel much stupider when I'm connecting OAuth flow because it's like just as hard as AI stuff, but then the pieces that are connected are just like Boolean values going back and forth of like, can I please be authenticated? Yes, you can. It's not driving a car, but I made some meaningful progress there, and I feel great about that. It's the Twitter API is kind of weird to be able to post a video on it. I would love to be able to just say, here's a URL to the video, slurp that up, and here's the body of the tweet. And instead of doing that, I need to have two separate API calls, one of them uploading the media directly to Twitter, so it's on Twitter servers, and then they send me back a media ID, and then I need to tell Twitter, okay, post this tweet with this specific ID. I think I know exactly what I'm going to do next, but I'd love to just talk through it and smooth it out and get your feedback on it. I have this machine right now that can take a video and with some human intervention, take this long-form video of like an hour and chop it up into interesting little pieces, and then I can turn that into a social media optimized thing of a square video with the title on top and the transcript on the bottom. And that's a video file that's then living in the cloud. I need to be able to connect that to this machine that I have on the other side that can, sometime in the middle of this week, will be able to take text and media and post that to Twitter. And I think what goes in the middle there is a queue. And so after I finished a clip, I'm going to say, yes, add this to the queue. Now I have a list of a bunch of clips. And then I say, please post one clip every day on every social media feed at 9 o'clock. And then I just have a cron job that is looping, looking for the next job. And as soon as that it makes sense to post another post, it grabs one off the top. It knows what the title is. It knows if there's any extra text you want to do with it. It knows where the video is. And then it goes through all of my social media connected accounts and posts that clip on each one. Does that sound about right?
Sounds reasonable.
Cool. I think that might be done this week, which is very exciting. Stuff's happening.
Yeah.
It feels good.
I felt exactly the same way when I was doing Slack's OAuth stuff as you did when you were doing Twitter. It's like it took me like 2 or 3 days, and by the end of it, I had like 2 API endpoints, and I had to call 2 of theirs or something. And I was like, it was like 20 lines of code for like 3 days of work, and I was like, this is ridiculous. This is like regular web work, and but I don't know. I guess that's the game. You just got to keep reading documentation until it's done.
OAuth should not be that hard. Like, I've implemented this, a dozen times, and every time it's hard.
Yeah,
it shouldn't be hard.
It's like each service requires you to keep track of things in slightly different ways, and that's why like companies like Okta or OAuth exist. Or is a company called OAuth? Auth0. That's right. Auth0 or Okta, right?
Yeah.
Because then you do it once to Okta, and then that's like single sign-on to all your stuff. And so, yeah, that's why those companies exist. So you can just do it once, and it replicates it 1,000 times for you. And they charge a lot of money for it.
I forgot Auth0 was a thing. Would that give me API access?
I think Auth0 is more like, I could be wrong because I haven't used Auth0. I think it's more like you are the source of record. And so like if you want people to log into you, but it may cross log into Twitter. I have no idea, actually. I haven't used Auth0.
Okta is another one you said?
Yeah, Okta. Okta. Yeah, OK Okta. They are more enterprise, so that's like you call a salesperson and get a quote, which is expensive.
Yeah. Gross.
That's the one I've dealt with.
Okay. Yeah, that's not... What do I want here? What would make this really easy? Something Firebase does that I love is it's just like checkboxes, and they just have their standard way of doing things, and then to implement another OAuth sign-in, you just check a box, and maybe you copy and paste your keys, and then it handles everything on the back end. But I think what I want is for things that require OAuth for APIs, I would want to be able to, I don't know,
just check a box, right? Except you still have to, just check a box. I'm sure that's a service. Like, I bet Auth0 does that. Maybe not, though. I should look that
It's
up
a harder
before I
problem
say
though,
anything.
because interacting with APIs, like, I think what I'm looking for is just standard client libraries for everything. Maybe I want better client libraries, but then it's like I'm just passing values back and forth. It's just like what am I sending out, and then what am I getting back? Maybe I want this built into Firebase is what I want. I want built-in Firebase plugins for every API I could be interacting with, and I want to be able to just say, like, here's my user document. Get this user document to a place where I can just start making API calls.
Yeah. That's kind of what
like,
Zapier is, actually.
Interesting.
Make a Zap that does a tweet.
Yeah. So then I would just integrate with Zapier. I'm curious if I'd be able to send video through that. Like for Twitter, I need to send Twitter. I need to upload to Twitter a video, and that's the sort of thing that I would be surprised if Zapier could do. Because now what, am I sending Zapier the video and then they're sending it to Twitter for me?
Zapier is more like a connector, so I don't think so. I would have to look that up. But this kind of brings up when you were talking about what you wanted to sort of reminded me of the whole no-code movement, which we haven't talked about, and we could, and that's a whole other thing. But it's like it works great until it doesn't. So like Zapier will work great unless it didn't quite support the video you wanted in the format you wanted or something like that, right?
Yeah.
It would be great unless it wasn't quite, and then you have to redo the whole thing anyway in code.
Yep.
Yeah.
Which is true of every abstraction. I've talked on a different podcast before about the no-code movement. That's no different than coding. Like comparing machine coding, comparing coding in assembly to now you can code in C. To the assembly programmer, C looks like no code. And then to the C programmer, JavaScript looks like no code. And then to the JavaScript programmer, okay, this WYSIWYG where you're just connecting things in Zapier looks like no code. But it's all still coding. We're just moving up the layer of abstractions. I'm personally not a fan of any click and drag GUI that I've seen for coding. Text is really effective at precisely defining exactly what you want to happen. And we have a lot of tools involved with manipulating text. There are programming languages designed around how quickly can you manipulate text, like V. And I have yet to see any compelling interface, with one exception, actually, now that I'm saying that, which is VR. Coding in VR is very interesting because you're taking physical blocks of things and connecting them. And that makes a lot more sense to me than it's in the computer. And things like Max MSP, I think, are one of the more advanced, like, real programming languages that's entirely GUI based. But in VR, I have the feeling that I'm inside the computer, and it's limited, and you run up into the ceiling pretty quickly. But I can see the potential of that we could get to a point where you could program in VR, and programming would look much more like you take these boxes and you move them in a way that to your brain makes sense spatially, hierarchically. And if you want to go inside of one of the boxes and see what's in there, you can do that. And, an if statement looks like this, and maybe we have an analogy of that it looks like water flowing or something. So you can much more visualize how data is moving through your code, and then you can collapse that back into a box. That's sort of like Tony Stark interface of that you're in the computer. That may be a more compelling interface than coding in text. But until then, text, I think, is just like the most effective way of precisely defining what you want to happen.
Yeah. What I really would love to see, and I think might be coming, and I actually made some strides to this before, which is something like you code normally, like just normally. But then as soon as you have something like, I really want, Twitter in here, 10,000 people have implemented this at 10,000 times. I just want to tell an AI assistant to look at my code and slot in Twitter OAuth, exactly where it should go. That should be a solvable problem. Yeah, exactly. I started doing this for designs. So as a consultant, I would get like sketch files, like Figma, Sketch, whatever. And then I had to turn those into like React Native components, right? Mm-hmm. And so I wrote a thing to parse the sketch file and automatically build components for me.
That's so cool.
And it sort of worked. And so, yeah, I think that's coming eventually. There's a little uncanny valley there. So if you remember Clippy from Microsoft Word, which is like, I want to help you with whatever. There's a little bit of that. And so if it gets it slightly wrong, then you're not going to trust it anymore. So you have to get it really right the first time.
Yeah.
But yeah, that's what I want.
I think I remember reading something on Hacker News about that. It was a search algorithm, or no, it was an array sorting algorithm in JavaScript. And the way that it worked was it searched Stack Overflow for a method to sort an array, and then copy and pasted the code, and then tried to use that function to sort the array. And I think it worked. And I think it got a different one each time. I'm having trouble remembering the specifics of that. But
That's pretty funny.
yeah, with databases like Stack Overflow, and I think GPT-3 is able to code some basic stuff. It's able to like code in HTML and make some
Sort of.
JavaScript things. Sort of.
It can produce code that looks like HTML, or Python or whatever. What you get out is nothing, but it looks kind of like it. Yeah.
That seems like it's on the path, though. I have one last question to sort of end this on more of a philosophical note. What are humans going to do when we have these? When you can just interact with a computer, and in the same way that you interact with Siri and say, like, what's the weather? You could interact with Siri and say, make me a positive feedback bot that gives me positive reinforcement when I tell it something. And it's able to make that. What do humans need to do now? What would you do if you lived in a world where that was possible? How would you spend your time?
So there are lots of responses to this already out there. I don't pretend to know anything. This is probably just a regurgitation of everything I've heard already. But people are very there's a few things. People are very adept at coming up with new things to do, and so we'll figure it out, right? The other thing is, like, someone's going to need to make the program that makes the program, or makes a program that makes the AI that makes the things, right? So for a while, that's going to be the deal. Also, like, so people say stuff like, if an AI can produce art, then what do artists do? Well, people only have some small amount of time, like attention, and so I think it's not going to be any different than before. You're going to have human artists using these AI tools to like create things, and then some amount of attention is going to be directed towards that. Like, in some ways, it's kind of like the banana tape to wall like thing. It's like a showcase of this. Like, it's just a banana tape to wall. It could have been someone hitting a thing on a keyboard. The thing that makes it interesting is not like the art or the thing that produced it. It's like the cultural significance, right? So there's going to be a different cultural significance in the future, and we will figure that out. That may not be a satisfactory answer, but yeah. What's your answer?
I don't know. I think I'm going to read a lot more and learn a lot more, and I don't know. I suppose life would feel much more like a video game. And I think I'd be looking for more things of consequence to do. I think part of the reason why you're drawn to Kaggle and why I'm drawn to the problems that I'm drawn to are that it feels hard and feels worthwhile and feels like it's going to help people to do stuff. And in a world where everyone can just sort of get whatever they want, I don't know how I direct that. Well, no, okay. So I think I'd be moving much more into problems of like helping humans, which is that's my direction right now. But I think I would be helping them in different ways. I think they're in a world like this. I think there's going to be a lot of traps to fall into of people making their own Lotus dens. That's sort of where we are now. People just dumping endless amounts of time into different news feeds and things. And I think the way to best help humans in that environment is to teach them ways to use those tools in a way that actually improves their life, as opposed to just sucking more time and attention away from them and sapping. I think there will always be help in helping humans to take their attention away from things that are damaging for them in the long term and towards things that are helpful to them in the long term. And that sort of coaching, I think, will continue to be difficult for computers to do directly. I think that's my answer.
Okay.
That's what
I was
right
about
now.
to say something about the utopian versus dystopian futures. Like that sounds like more of a utopian future, which is great, right? The dystopian future is something like in the 1950s, we thought we were all going to be, only working 5 hours a week now and whatever, and we're working harder than ever, which means in the future we'll probably be working harder than ever and pushing people into more inequality. And like it's there's very dystopian ways you can go very quickly. I think.
Yeah, gosh. I'm reminded of a short story called I Have No Mouth and Yet Cannot Scream that talks about this future where this AI takes over and delights in torturing humans and just comes up with some incredible ways to torture. Like, it can make humans immortal, but it's only for the purpose of torturing them. Yeah, that's a thing that could happen, and I choose to believe that it's going to be a utopia. instead of a dystopia. It is kind of wild though, thinking of what would people 100 years ago looking at our lives think of, like, hold on, you're telling me you have enough food and you have a huge house and it's the perfect temperature in your house all day, and like you need this much money to have these incredible, you have a refrigerator that can just keep food indefinitely, and you have a huge backyard that you could be growing an infinite amount of food in, and you're choosing to spend all your time going to work? How? Explain that. That doesn't make sense. You're working more hours than I am, and do you like your job? You don't like your job? What are you doing? Well, I got to make money so that I can buy tickets to be able to, like, fly to Europe 3 times a year. Why would you want to go to Europe 3 times a year? Like, you're in your place where you're living. Why aren't you happy there? Yeah, I would love to have a conversation like that with. I should talk to my grandpa more and see what his take on this is. He's had a wild life of the world has completely changed under him.
Yeah, that's what I mean by humans figure it out. I mean, we adapt so well to change, or I wouldn't say well, we adapt so much as things change.
We adapt to finding meaningful, difficult things to do, no matter what the situation is. No matter how many resources we have, we will always figure out what the thing is that we don't have enough of and direct all of our attention to getting more of it. Yeah, makes sense. Chris, that's all I got.
What a way to end. That's all I got too.
What a way to end. That's right. I'll see you next week. Goodbye.
All right.